All right, this is not only one of the toughest problems we've had, but one of the toughest probability problems we've had. So let's work through this together one step at a time. We have the same pedigree as before, talking about galactosemia, a rare autosomal recessive disease. And we've figured out that the man up top and the female here are the only two who are affected. And what we want to know is whether or not this couple's child is going to be affected by galactosemia. So we're going to have to figure out the probability that the people in between here are actually affected, or rather not affected, but are heterozygous carriers. And what's the probability of them passing it on? Let's start down here with the sister. She's affected. So we know because this is autosomal recessive, she must be minus minus. That means the parents must be heterozygous. It's the only way she could be affected, right? And the parents are unaffected. They both had to pass on an allele. Right? So they must be, that's a probability of 1 for each of those. If they mate and produce the female here, there are several options. Two heterozygous people come together. We can have plus plus, plus minus, or minus minus. But the thing is we know she's not affected at all. So this possibility is completely removed from our equation. There are only 3 possibilities here. Plus plus, plus minus, plus minus. 2 out of the 3 possibilities are heterozygous. So there's a 2/3 probability that she is a carrier or heterozygous. Now let's look at the father's side of the pedigree. We know that the maternal grandfather was affected, so he's affected, he's minus minus. We assume marrying in from the outside, you're plus plus. And so the male can only pass down an affected allele. She's unaffected, so we know she must be heterozygous. That's a probability of 1 that she's heterozygous. We assume that mating in from the outside, you're homozygous unaffected. The probability of this heterozygous female passing the affected allele down would be 1/2, right? She can either pass this allele down or that allele down, and it's 1/2. And now we have 2 parents. If we assume their probability half probability of heterozygous here, 2/3 probability of heterozygous here. If you make 2 heterozygous individuals together, the probability of them having an affected offspring is 1 out of 4. So that would be 1 out of 4. So we have our 3 probabilities. I'm going to ignore every time we had an instance of 1. We're going to take 1/2, multiply it by 2/3, and multiply it by 1/4. The 2's cancel out, and so I get 1 over 3 times 4, which is 12, or 1/12 would be the answer to this question as the probability that this couple's child would have galactosemia. Now don't be discouraged if this was difficult. This is a difficult problem, but working through it slowly, step by step, you get an idea of how difficult it can be to work through all these probabilities and percentages. And you also become keenly aware of these assumptions we're making along the way about people who made in from the outside and what the possible options are of where these alleles come from.